Hello everyone. This time I will take some example for you about how to solve about linear equation in real number and how to solve system of linear equation in real number. The first video which I discuss on about the in general or about the definition, about the property of linear equation, of system of linear equation. But other way, this time I talk about how to solve about linear equation in real number. So in real number, sometimes they can just led by letter O. Letter O is the symbol of real number. This is real number. The first exercise, they want us to solve about x1 plus 2x2 equal to 5. So we know already this is the linear equation, or sometimes we call about the straight line in our lesson. Or to solve about this equation, we should be know that how many equations of this exercise and how many unknown of this exercise. This exercise have one equation and two unknown variable. So if we want to find about the solution of this equation, we should be know one of unknown variable. But now we don't know about x1 and x2. If we want to find the solution of this equation, we should be find about the first we let x2 equal to t, and t is belong to real number, to all. So now I get x1 plus 2t equal to 5, and I got x1 is equal to 5 minus 2t, where t is belong to real number. So this is the solution set of our equation, because this set is changed by our parameter t, because t is belong to all, start from the negative infinity to the positive infinity. And point 2 is also the same. Point 2, because point 2 is, I write about the equation of point 2, x1 minus x2 plus 3x3 equal to 6. So this equation have unknown. If we want to find the solution of this equation, we should be know about two unknown, the value of two unknown. So I can let the first we let about x2 equal to t and x3 equal to s, where t and s is belong to real number. Now we got the equation, we can substitute x2 and x3 by t and s. We got x1 minus t plus 3s is equal to 6. So we got x1 is equal to 6 plus t minus 3s, where t and s is belong to real number. So this is, we can call the solution set of our equation. But sometimes we can change this solution by our solving. So in point 2 or point 1 we can change about the solution set of the equation. Example, in point 2, if I let in point 2, this point 2, if I let about example, I let x1 equal to s and x2 equal to t. So we get our solution is s minus t plus 3x3 equal to 6. So we got 3x3 equal to 6 plus t minus s. So x3 is equal to 6 plus t minus s over 3. So this is we get about the general solution of our equation x1 s, x2 t, and x3 6 plus t minus s over 3, where t and s is belong to real number. So we can change about this solution or about the solution set of our equation by our letting unknown variable. And point 3 is x1 plus x2 minus 2x3 plus x4 is equal to minus 2. So I can let the first, in general they let about x4, x3 and x2 to find the x1. So if I let about if we let x4 equal to, like I use m, x3 equal to n, and x2 equal to o. So we got our solution, our equation is x1 plus x2 is o, I let p, o is compute to 0, p minus 2n plus m equal to minus 2. So we got x1 is equal to minus 2 plus 2n minus p minus m. So our solution has the solution set is x1 equal to 2n minus 2 minus m minus p, and x2 equal to p, and x3 equal to n, and x4 equal to m, where m and p is belong to real number. So this is the general solution set of our equation x1 plus x2 minus 2x3 plus x4 equal to minus 2. This is the way to find about the general equation of our equation. And the next point I just talk about solve the system of linear equation by Gauss elimination. If we want to solve about this equation, this system of linear equation by Gauss elimination, the first we should be convert from the system linear equation to be AM. AM, it means to Archman matrix. So we can get about the Archman matrix. Archman matrix is the matrix that we write only coefficient of the system of linear equation by in the bracket or in the rectangle array. So we got 3, we got 1, we got -1 and 12. I write here 12 in the right hand side. And the next is 1, -1 and 1 equal to -8. And the next is 4, -2 and 1 and -8. In this case, in our arrangement matrix, we can change a change between row 1 and row 2, row 1 and row 3, row 2 and row 3, and etc. So now I change from row 1, 1 is row 1 with row 2. If I write like this, it means that change row 1 to row 2 and row 2 to row 1. So I got our new matrix is, arrangement matrix is 1, -1, 1. And 12, no, sorry, not 12. This is -8. -8. And 3, 1, -1 and 12. And the next is 4, 2 and 1 and -8. We want to solve about this equation by Gaussian. Gaussian, it means have the general form. The general form of Gaussian is like A11, A12, A13, like this one, equal B1, and 0, B22, and B23, B2 or A, I just write A, and this one is 0, 0 and A33 equal to B3. This is the general form of our Gaussian elimination. So the first we should be convert from 3 and 4 to B0 by our operating with row 1. So I just write row 1 is the same. Row 1 is get from row 1. Row 2. Row 2 is get from row 2. If this one to be 0, so we should minus 3 row 1. 3 row 1. And row 3 can be get from row 3. This is 4. This is 1. So minus 4 row 1. So now we got our new arrangement is 1, -1, 1, and -8. This one -3, this one. This one multiplied by 3 is -3. 3 minus 3 is 0. This one is -3. Minus plus minus is plus. 1 plus 3 is 4. So this one is 4. Minus 1 and minus 3 is minus 4. Minus 4. And this one 12. This is minus 8. 8 times 3 is 24. 24 is plus is 36. So this one is 0. This one 2. 2 minus 4 times this one plus 4. Minus 2 plus 4 is 2. This one is 1. 1. This one is 4. 1 minus 4 is 3, because this is 1, this is 4. So this is 8 is 32. 32 minus 4 multiplied by minus 8 is 32. 32 minus 8 is 24. So I write 24 here. 24 here. And the next I should be convert this one to be 0. To be 0. So we keep, or I just find another solution. This easy than this one. I don't want to write this one to be 0. First I convert this one to be 1. So we write about O1 come from O1. O2 is come from O2 divided by 4. And O3 come from O3. So we got our arrangement matrix is 1 minus 1, 1 and minus 8. So this one is divided by 4 is 0. 1 minus 1 is divided by 8 is divided by 4. Yeah. So divided by 4 is 9. This one is 0, 2, 3 and 24. And the next I convert the row 3 of column 2 to be 0. So we just write about this one. I just write O1 become from O1. O2 become from O2, and O3 become from this one to be with row 2. I just O3 minus 2 or 1. So we got arrangement matrix is 1 minus 1, 1 and minus 8. This one is 0. This one is 1. This one is minus 1. This one is 9. This one is 0. 0 minus 0 is 0. This one is times 2. 2 minus 2 is 0. 3 minus 2 minus plus minus is minus multiplied by minus is plus. 3 plus 2. 3 plus 2 is 5. Is 5. And this one is 2 is 18. 18. If this one is 18, 18, 24 minus 18 is 6. Is 6. And this one. So this is the end of our equation. We should be convert from arrangement matrix to the system of linear equation. We got x1 minus x2 plus x3 equal to minus 8. And x2 minus x3 equal to 9. And 5x3 equal to 6. This is equation 1, equation 2 and equation 3. So we find about the equation 3. We got x3 is equal to 6 over 5. And the next equation 2, we got about x2 minus x3 is minus 6 over 5 equal 9. So we got x2 is equal to 9 plus 6 over 5. So we got x2 is equal to, this 35 is 51 over 5. And the equation 1 is x1 minus 51 over 5 plus 6 over 5 and equal to minus 8. So we got x1 minus this one is 35. 35 divided by 5 is 9. 9 equal to minus 8. So we got x1 is equal to 1. Our system linear equation is, so we got our solution. So solution of linear equation is x1 equal 1, x2 equal 51 over 5, and x3 is equal to 6 over 5. This is our solution of linear system of linear equation. And the other point we have about the system of linear equation, but the system we call about homogeneous is homogeneous system of linear equation. Homogeneous system of linear equation is the system of linear equation that the right hand side is equal to 0. So if we want to find about this one, we should be convert from this equation to the H-man matrix also. So we got about H-man matrix is 1 minus 1 1 4, and this one is 0, 2 1 minus 1 minus 2 0, 3 minus 1 2 and 1. This is 0. So the first Gaussian elimination, we want about the next column of next row of the first row, row 2 and row 3 of column 1 to be 0. So we convert 2 to be 0 and 3 to be 0. So now we just write, I write O1 from O1. O1 is from O1. O2 is from O2 minus 2 O1, and O3 is become from O3 minus 3 O1. So we got our H-man matrix is 1 minus 1 1 4, and this one is 0. This one row 2 minus 2 row 1, so is 0 minus this one minus and minus plus 8 3. This one is minus 3. This one minus 2 times of this one is 10, minus 10. Minus 10, and this one is 0. And the next is 0. This one minus 3 times of this one. Minus 3 times minus 1 plus 3 is 2. This is 2 minus 3 is 1. this 1 minus 12 is 11. This one is 0. And the next we convert the row 3 of column 2 to be 0. So we get R1 come from R1, R2 come from R2, and R3 come from, this one is 2. 2 and 3 is different coefficient. So I write 3 or 2 minus 2 or 3 or 3. 3 or 3 minus 2 or 2. So now we got our arrangement matrix 1, minus 1, 1, 4, and 0. This one is 0, 3, minus 3, and minus 10. Minus 10 and 0. This one is 0, this one is 0. But 3 this one, minus 2 this one. 3 plus 6 is 9. This one is 3, this one is 6. 3 plus 6 is 9. This one is 32. 33. 11 multiplied by 3 is 33. Minus and minus is plus. 33 plus 33 plus like 20. So is 53. This one is 0. This one is 0. And now we got, we can convert from this equation, from this arrangement matrix to about system of linear equation. We got x1 plus x1 minus x2 plus x3 plus 4x4 equal to 0. This one is 3x2 minus 3x3 minus 10x4 equal to 0. And 9x3 plus 33x4 equal to 0. So now we got, this is the equation 1, equation 2, and the equation 3. So we just find about the equation 3. Our equation 3 is 9x3 plus 53x4 equal to 0. This is one equation but have two variables, so we cannot solve, we should be let. I just let x 4 equal to t. Now we got 9x3 plus 33t equal to 0. Now we got x3. x3 is equal to minus 33t over 9. This one t is belong to R, and this t is belong to R. And the next we go to the equation 2. Equation 2 is 3x2 minus 3x3. Minus 3x3 is minus and minus 55, 53t over 9 and plus 4x4 is 4t equal to 0. So I have 3x2 minus and minus plus 53 over 3t plus 4t equal to 0. And I got 3x2 equal to minus this one is 12 and 65 is equal to minus 65 12 this is 12 times 12 minus is 65 over 3t. So we got x2 is equal to minus 65t over 9. As t belong to all. And the next we should be find about the equation 1. Equation 1 is I write over here. The equation 1 is x1 minus x2 plus x3 plus 4. Oh, this one is not 4. I'm sorry. This one is minus 10. It's minus 10. Minus 10 is minus 10. So this one is minus 10 is minus 10. 10t is 30 is 83 is 83 is this one is minus 30 is 23 this is 23 over 9. So the equation 1 is plus 4x4 equal to 0. So we got x1 minus x2. Our x2 is 23 over 9t plus x3. Our x3 is minus 53 over 9t and plus 4t. 4t equal to 0. So x1 minus this one is 73 over 9 t plus 4t equal to 0. So we got x1 is equal to this is equal to 3 over 9t plus minus 4t. So we got x1 is equal to 36. So x1 is equal to this is 36. 36 is 34 is 37. 37 over 9 is t. So we got about the our solution is x1 equal to 37 over 9t. x2 is equal to minus 23t over 9. x3 is equal to minus 33 over 9t and x4 equal to t, where t is belong to real number. So this is our general solution of the equation. So now I got you 3 examples about linear equation, system of linear equation, and homogeneous system of linear equation. You can watch this video, and you don't know some point, please take a note and ask me back when we meet in our classroom or in our meeting room. Thank you very much. See you next video. Bye bye.